Okay, we're going to do some reviewing on mole-to-mole problems, and we are going to start with where we left off on Friday. So if you recall, the first thing you have to do when you're doing mole-to-mole problems is balance the chemical equation. So the equation is the same equation that we had for the previous two problems. And to balance, it's 1, 3, 2. To review, we have to write down what we're given and look to see what we're trying to find. So we are given 2.75 moles of NH3. That means moles of NH3 has to go on the bottom. Recall, whatever unit is here, that's the same unit that has to go down there. Not the number, just the unit. Moles of what you're looking for goes on the opposite side. If you look right here, since we're given moles and we're asked to find moles, we know this is a mole-to-mole problem. And when we're doing a mole-to-mole problem, we use the coefficients from the balanced chemical equation. So moles of N2, the coefficient's 1. Moles of NH3, the coefficient's 2. When you solve this, you take the number that you're given, 2.75, multiplied by what's on top. So you take 2.75 times 1 divided by 2. Your moles of NH3 cancel, and you're left with 1.38 moles of N2. Since I have 3 sig figs in the beginning of the problem, I'm going to have 3 sig figs at the end of the problem. So this is my answer. Any questions on that one? Feel free to ask. There'll be plenty of time during class. Okay, the next thing we're going to do, we're going to do number 7. So again, we have to start off with the balanced chemical equation, and this would be 2, 1, 2. We're given moles of oxygen, and oxygen is one of your diatomic elements. Remember, horses, horses need oats for clear brown eyes. All right, so we are given 5 moles of O2, and that means moles of O2 has to go on the bottom. We're looking for moles of water. So we know it's a mole-to-mole problem. Mole-to-mole. The hardest part for you guys is going to figure out what type of problem this is. Moles of H2O go on top. Since it's a mole-to-mole problem, mole on top, mole on bottom, where do we get the numbers? Get them from the coefficients. So 2 goes in front of the H2O, and 1 goes in front of the O2. Your moles of O2 cancel, and you are left with 10 moles of water. And since I only had 3 sig figs here, I used 3 sig figs there. This one, I'm given 3 moles of water, and we're looking for moles of oxygen. Again, oxygen is your diatomic. What unit has to go on the bottom to cancel? Your moles of water. What's going to go up top? Moles of O2. What numbers go here when you have moles on top and moles on bottom? The coefficients from the balanced chemical equation. So 2 is in front of water and 1 is in front of O2. Your moles of H2O are going to cancel. When you solve this, you take your 3 times 1 divided by 2, and you are left with 1.50 moles of O2. And this last one. I'm given 3 moles of water and I'm asked to find moles of hydrogen gas. Hydrogen gas is H2, water's H2O. Since I'm given moles and asked to find moles, I know it's a mole-to-mole problem. So I'm going to start by writing down my 3 moles of H2O. Moles of H2O has to go on the bottom to cancel. Moles of your hydrogen gas goes up top. Moles on bottom, moles on top, so you have to look at the balanced chemical equation up here and put your coefficients in. 2 goes in with both of them. Your moles of water cancel, and you are left with 3 moles of hydrogen gas. Those are easy mole-to-mole problems. Easy mole-to-mole problems. But I just want to give you a little heads up on what we will be doing. What we will be doing here. So, say that we have N2 plus H2 yields NH3. And to balance those, we put a 3 and a 2. What if I asked you how many grams are in 28.5 grams, moles of NH3. So our problems are going to start being mixed up now. So it's going to be a little bit challenging for you guys to figure out what to do. So you always have to make sure your units are in the correct positions. So for this problem right here, I am given my moles of ammonia. So that's what I have to write down. I'm asked to find grams. I'm not changing substances. They're asking me to find grams of ammonia. So this is a very same problem you did at the beginning of last week. What unit has to go on the bottom to cancel here? Moles of ammonia. What are we looking for? Grams of ammonia. When we did these problems before, whenever moles was opposite grams, what number always went with moles? A 1. Where do we get the grams number at? You add up the N and the 3 H's from the periodic table. So N is 17.0. N is 14.01 grams. And H is 1.01 grams. And you have 3 of them. So when you add those up, you get 17.04 grams of ammonia, because we always take it to 2 decimal places. Your moles of NH3 will cancel. Take your 28.5 times 17.04 divided by 1, and you're left with 485.64 grams of ammonia. So that's a little refresher on what we did before mole-to-mole problem. So we did moles to moles when you change substances, and just a regular stoichiometry problem when you're keeping the substance the same. I want to switch it up a little bit though. I want to know how many grams of ammonia can be produced from 10 moles of H2. All right, you've never had a problem like this before. So you're given 10 moles of H2 and you're asked to find grams of NH3. It's not a mole-to-mole problem. So, and you're switching places. So you're going from H2 to NH3. So you're changing substances. So let's start like we always do and write down what we're given. So we're given 10 moles of H2. What unit has to go on the bottom? Moles of H2. Now, how am I going to get from H2 to NH3? We can do a mole-to-mole problem to begin with. Right there. Where do I get the numbers that go in front of here? My coefficients from my equation up there. The 3 goes with the H2, and the 2 goes with the NH3, and your moles of H2 cancel. But this gives me moles of NH3. I don't want moles, I want grams. That means you have another step. 1 mole of NH3 on the bottom, grams of NH3 up top, and you add them up from the periodic table. Your moles of NH3 will cancel. Now you take your 10 times the number on top, 2, divided by the number on the bottom, 3, times the 17.04 divided by 1, and you get 113.60 grams of NH3. So this is coming Wednesday. This is where we're combining what we did with mole to mole and what we did with previously mole to mole. Okay? So if you look on the calendar, I have a worksheet for today, which is majority mole to mole. And I have a worksheet tomorrow, which is mole to mole, mole to mass, and mole to molecules. I have a short, maybe 5-question quiz on Wednesday. You will definitely have to balance equations. In order to do mole to mole problems. You will then maybe have mole of A to mass of A, which we did first, or mass of A to mole of A, and you may see a mole of A to molecules of A. To do the molecules and problem, remember, say that we're given 5 moles of, I don't know, let's make something up, CH4. 1 mole of CH4 on the bottom, and you know that there's 6.02 times 10 to the 23 molecules of CH4 on top. Your moles of CH4 will cancel. You'd be left with 3.01 times 10 to the 24th molecules of CH4. Okay, so I've given you examples of all these problems. Now we're going to use the remaining time in class to work on our homework. If you have any questions, I'm here. That's why I'm giving you time in class, in case you guys get stuck. All right, thanks.